first packet of workbook pages, 189 to 204. Please turn to page 202. We need to talk about the equation of a circle. In Algebra 1, you should have learned the different forms that the equation of a line could be in. There was slope-intercept form, and I feel as though most Algebra 1 teachers just hail that as like the only form, and everything goes back to that. And it is extremely important, but there's other forms of an equation of a line. You can have standard form, which is ax plus by equals c. Well, same thing with circle. And there are standard forms of an equation of a circle. That's what we need to write out and discuss really quickly. So in between number 1 and number 2, because you weren't assigned either one of those, we need to write standard form and then in parentheses I'm going to put equation, like we know that this is a form of an equation of a circle is, and then colon. Standard form, and we're talking about the equation of a circle, is, in a set of parentheses, the quantity x minus h, and I'm trying to make my variables in cursive, script, plus, in another set of parentheses, quantity y minus k, quantity squared. Again, I'm trying to make it so that these variables are looking in cursive, and that equals r squared. This is the standard equation, a standard form, the equation of a circle. Can anyone take a shot at what r is?
Radius.
The radius. Sorry, that's pretty self-explanatory. However, this whole h and k thing, they are the coordinates of your center. So we're talking about putting these on a Cartesian plane. And so h and k are your coordinates of your center. So we're just going to quickly identify. I'm going to say, hey, r, that is your radius. And then we've got h and k, coordinates of the center. Now, looking at this standard form of the equation, what does it kind of resemble? Pythagorean theorems. Those of you who said distance formula totally agree, because that's also an application of Pythagorean's theorem. I mean, that theorem is just crazy important, and we have proven so many things using it. But here's a diagram that maybe just sheds some light on how it is an application. So this is all variables, but we have some circle with some center, h and k. And so this hypotenuse of the right triangle, the value of c, is the radius. And to find those other legs, values of a and b, it would be the difference of whatever your whatever your x value is of the point that's on the circle, minus the x value of your center. And then to find the height, the other leg, it would be the difference in the y values, whatever point is on the circle, and then your center. And so this equation will spit out all of the x and y values that satisfy this equation. That is that given radius away. So yeah, but it definitely is just an application of Pythagorean's theorem. So, if that's the case, we'll do number 7 together. We'll do number 7 together. And we're just going to plug these values into the equation of a circle. And so the equation is x minus h. Well, h is the x coordinate of my center. So in that first set of parentheses, it's going to be x what? Plus 3. Because you're subtracting a negative 3. When you subtract a negative number, that's like adding. So it's going to be x plus 3, quantity squared, plus y minus 0, quantity squared, is equal to 5 squared. Just plug in these values. And so let's go ahead and see if we can simplify. I can't simplify anything in this first set of parentheses because those are unlike terms. However, in the second set of parentheses, I've got y minus 0 is just y. And so we're squaring that, so this is just y squared. And then we can compute 5 squared, which is 25. You're done. I mean, that's it. They're asking for the standard equation of the given circle. So there you have it, right there. Go ahead and jump over to page 203. And go ahead and look at number 17. Number 17 reads, x squared plus y squared equals 100. The instructions say to determine the diameter. What is the length of the diameter? Can someone quickly, right now, tell me the diameter of this circle?
200. No. 20. Right?
What does this represent? So we got 100 right here. This is radius squared. So Kobe, what's the radius?
10.
It's just 10. What's the diameter?
20.
20. Okay. Somebody else said that. I heard it. I heard somebody else say it. But it was after 200, 100, like so. Anyway. So let's try it one more time. What's the diameter of number 20?
18.
18. 18. Sweet. So this stuff is pretty basic. I mean, it's pretty easy, the equation of the circle. The last thing that we need to talk about, you need to get a blank sheet of paper. Blank sheet of paper. I have no idea. Please don't. No one would enjoy that.
No. She made us write an essay in 45 minutes this morning.
Yeah.
Like, entirely in class.
We're gonna have to do that a lot.
45 minutes? Yeah, I don't like it. Not 15 minutes. Yeah, I have the first block, so we had a certain class.
You're gonna hate
All right, here we go. So we've got, I want you to draw on the left-hand side of your piece of paper, or write circumference and then the formula for it. And then on the right-hand side, you're going to draw area, or write it. You're going to write area. And in between circumference and area of a circle, I want you to draw that diagram. It doesn't need to be perfect. Obviously, my circle isn't perfect. But I do want to make it clear that this is the center. This is the center. I'm trying to put a big old dot there, because I do want that to be the center of the circle. The main thing I want to talk about today before we get out of here is, just like trigonometry, there were exact answers and then there were rounded answers. When we deal with circumference, when we deal with area, I mean, this is the new stuff, but arc length and sector area, there's going to be a difference between the exact answer and the rounded. The formula for circumference is 2 pi r. That value, or that constant, pi, it is an irrational number, and which means you cannot represent that value as a fraction. We can get an estimation, we can get a rounded value of it, and so I think that most of you would replace pi with 3.14, or maybe even 22 divided by 7. That will no longer happen ever again. We will never replace pi with 3.14. Don't ever, 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 ever do that. Instead, we're going to use our calculator, because the calculator has a much more accurate approximation of pi. And so if you look at the button underneath clear, that button's secondary function is that symbol pi. So you will hit the blue second button first, and then hit that button underneath clear. And it will actually like print out whatever the symbol pi. And then if you press enter with only that symbol pi, it'll get you a much, much more accurate approximation of pi. That's 3.141592, blah, 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 blah. That's why last year was crazy important and people were freaking out about Pi Day. Yeah, I don't know what I'm talking about either. Well, yeah, it happens every year, there's Pi Day, but like last year it was 3 and then 14, that is Pi Day, 3/14. But then it was like 15 was the year, 2015, and so like at 9:26 and 54 seconds, like math nerds across the world were just like.
My friend has a shirt and it said "I lived through" and then it said Pi Day and then the 3.14 and then the times.
So it was pretty epic this year. That's not gonna happen until another 100 years. I'm not gonna be here for sure. So it was exciting. It's kind of cool. Anyway, so we're gonna use that button. We're gonna use that button. If I ask you to solve for this circumference, there will be times when most likely 9 times out of 10, I'm gonna ask for the exact answer, and that means in terms of pi. And so if we plug in the value, we've got 2 pi, and we have 4 inches being the radius. Now we can simplify this. All we're doing is multiplying these 3 values. This is a constant, an integer 2, that's an integer 4, and we have this irrational value pi. When I want an exact answer, pi will be in your answer. There will be no rounding. You will not replace pi with 3.14. Pi will be in the answer. So the circumference of this circle is exactly 8 times pi. There is no rounding. There is no replacing pi with 3.14. There's no approximation. It is exactly 8 times pi. Now, we can type this into our calculator and use the pi symbol. And so I'm going to type in 8 times and then use the secondary function to get that symbol pi. And you're going to get a very long decimal on your calculator, 25.13274123. That's what we want. That's the estimated. That's the rounded answer. We're going to round to the nearest. And notice I'm still going to use the squiggly lines because this is no longer exact. We're rounding. We're going to round to the nearest hundredth. That's different from what we've been doing. We're going to round to the nearest hundredth. So it's going to be 25 point what? 13. I'm going to be very particular about units in this unit. in this next topic. I need to see the units. Let's go ahead and do the area. Who remembers the formula for the area of a circle? Pi r squared. Area is units squared. So we need to square the radius, so we have units squared. So the area for this is going to be exactly 16 pi, what's my units? Inches squared. So the area is exactly inches squared. What's an estimation? What's a rounded answer for this?
50.27.
Is it 2.6 or 2.7?
2005.
2.7. I heard y'all saying 6, so I trusted you. So we have an exact and we have a rounded answer for the circumference and the area.